welcome back to the Geog 300 Geographical Data Analysis video series for WVU. We're continuing on in our point pattern analysis topic, looking at the idea of what does it really mean for a point pattern to be random. And there is a precise term for that, complete spatial randomness. Complete spatial randomness, it's in a sense going off of the idea of independence, where every point is independent of all the other points. So there are two parts to this, two assumptions of what it would mean for every point to have a location independent of all the other points. So the first one is that any point can be located anywhere in the study area with an equal chance. So when it's, again, going back to that idea of the darts player, they throw that dart and it can land anywhere on the dartboard equally likely. They could hit any single portion of that dartboard. It could be the bullseye. It could be the edge. It could be somewhere kind of in between the two. That point can be found anywhere in the study area with an equal probability. So if we think back to the examples of clusters that I gave, where I said it could be that there is a soil type that those trees prefer, that would break this particular assumption. Could explain why it's clustered. This assumption is broken because it's not equally likely anywhere. It's preferential in that one corner that had the right soil type. So we have that assumption here. Any point can be anywhere with an equal probability or equal likelihood. The second assumption gets really to the heart of the independence thing, where any point's location is independent, unrelated to any other point's location. And again, to illustrate this with the non-random examples, I had an example of that in both the clustered and the even distribution. In the clustered distribution, there is could be a direct dependence when I said the seeds don't travel very far. The location of that first parent tree could follow this first assumption. And at that point, any others still follow that first assumption. They're likely to be they could be anywhere in the data set, anywhere in the study area. But that statement that all of the children of that first tree have to be near the tree, the parent tree itself, that breaks the second assumption. Because now the location of the children is dependent upon the location of the parent. There is that connection. They are not independent of each other. On the opposite side, when I gave the example of, say, a shade tree, but it needs sunlight for the seeds to germinate. That means the seeds and the children have to be far away from the parent tree. They cannot be under its canopy. That then says, okay, if they're far away, there's still that connection. If I tell you where the parent is, you have information about where the children are or are not. Just that in this case, it's that the children are far away. instead of nearby. There is that relationship, that dependence from one point to another, breaking the second assumption. These two assumptions, that points are equally likely anywhere in the study area, and that points are located independently of each other. This leads to the two broad categories of tests for complete spatial randomness. There are tests that are based upon the distance between pairs of points. Distance-based approaches would fall afoul. We'll be testing this second assumption, because if there's something going on with those distances, if two points are close to each other, or if they're all far apart from each other, then they're not independent. And we have a point pattern. We have something that is not random, because the distances are too long or too short. They don't match the distribution of distances under a random point pattern. The other approach is based upon density. So are there parts of the study area that have a higher density of points than they should? Or lower density? That would be breaking this first assumption. If there are parts of the study area where there are too many points or too few points, then they weren't equally likely to be found anywhere. So those are the two different approaches to studying point patterns. The next two videos will look at those in more detail, one on distance-based methods, one on density-based methods. So, as always, if you have questions, please feel free to ask, either in the Zoom classes, by email, however you want to reach out, please ask. Thank you for watching. Have a good one.